Good morning, everyone. My name is Martin Donnelly. I'm from the Digital Curation Centre at the University of Edinburgh, and this presentation is on research data management. What do support services need to know and do? Basically, a very quick introduction to research data management, what it is and how it affects researchers and those involved in supporting them in their work. Apologies for not being present in Cork. I had expected to be in Cork just now, but unfortunately I have a family situation that I need to be at home to deal with. So for those who weren't at the session yesterday, that's me. It's nice to put a face to a name. And what I'll talk about over the next 20 minutes or so is research data management, a little bit of an introduction and some definitions. I'll talk about the drivers for research data management, why it's come to be quite a hot topic in European academia, and then some specifics, what it actually means for researchers and what it means for support staff. So, what is research data management? I don't think there's an entirely satisfactory definition just yet, but the best one that I've come up with is the active management and appraisal of data over the life cycle of scholarly and scientific interest. The word that I have a problem with in that sentence is scientific, because obviously research spans more than just the sciences, but a lot of the research data management impetus came from the sciences, and there's sometimes a sort of chauvinistic science equals research attitude there. But the important word isn't scientific. The important word in the sentence is actually active. Research data management is something that requires active participation from a range of different stakeholder types, from the researchers themselves to the funding offices, the IT services, the library, compliance people, all those kinds of people. The types of activity range from planning and describing data-related work before it takes place, documenting data so that others can find and understand it, storing the data safely during the lifetime of a project, depositing it at the end of the project in a trusted digital repository, and linking publications to the datasets that underpin them, so that essentially the evidence and the conclusions of research are held together and people can query one or the other or both. And it's not just people like me who consider data management to be a vital part of good research practice. They are in the UK, the RCUK, which is the umbrella body of public funders, considers it to be so as well. So, what is data exactly? There's no one-size-fits-all definition for data. It will vary from discipline to discipline and from funder to funder. I like to contrast the arts and the sciences, given that I have to deal with scientists quite a lot, but I actually come from an arts background myself. So a science-centric definition of data is the recorded factual material commonly accepted in the scientific community as necessary to validate research findings. So I've emboldened in that sentence the key words, which are factual and validate. So that's quite clear cut. It's basically data is factual, and it is the evidence which validates the research findings, which are normally disseminated via publications. Another definition from the visual arts is that research data are evidence which is used or created to generate new knowledge and interpretations. Fair enough. Evidence may be intersubjective or subjective, physical or emotional, persistent or ephemeral, personal or public, explicit or tacit, and may be consciously or unconsciously referenced by the researcher at some point during the course of their research. So you can see the difference in definitions there. One is very clear cut and quite short, and the other is quite sprawling. And I know that if I was to pick one of those types of, or one of those definitions of data to manage, I would probably be picking the first one, because you know where you are with factual material, and managing subjective, emotional, ephemeral, tacit, unconsciously referenced data is probably a considerably trickier endeavour, but that's an entirely valid position statement for the visual arts, and it's something with those of us who kind of support the research process have to be sensitive to the nuances and the differences between different disciplines. So I mentioned that data in the sciences is commonly held to be factual evidence. In the arts, it can be a little bit more fuzzy than that, and indeed the term data itself is increasingly being seen to be inadequate to capture all of what the funders and other bodies want to be managed actively for the longer term. So the term research object is gaining in popularity, especially in the humanities, where the relevance of the term data is not always immediately recognised. As in, I don't deal with facts, I deal with opinions, that sort of thing. So research objects can comprise any supporting material which underpins or otherwise enriches the written outputs of research. So that can be data, and be that numerical data, written textual data, audiovisual data. It can be the software code by which the data is produced. We could be talking about the workflows and methodologies which help to understand the research process, or we could be talking about what would in previous years have been called grey literature, the slides, the logs, the lab books, maybe even the sketchbooks, notebooks, which kind of underpin the research process. It really varies from project to project, from discipline to discipline. But research object is a much more inclusive and wide-ranging term than data. So the point is that whenever you hear me say data over the rest of this presentation, it's more than just facts and figures. It's more than numbers and spreadsheets. So what are the benefits of taking an active approach to research data management? First and foremost, and this is the argument which is most popular with researchers, is the transparency argument, which is that the evidence that underpins research can be made open for anyone to scrutinise and attempt to replicate findings, and that drives up the quality of research. There's the efficiency argument, which is popular among funders, as in they fund data collection once, and that data can be used many times for a variety of purposes, and oftentimes these are purposes not foreseen by the original creators of the data sets. There's the risk management angle, which is that a proactive approach to data management will reduce the risk of inappropriate disclosure of sensitive data, and sensitive data can either be commercially sensitive or ethically sensitive, as in personal data pertaining to living humans. And there's the preservation angle, which is popular among librarians. Lots of data is unique and can only be captured once. If it's lost, it can't be replaced. Therefore, for data that cannot be regenerated, it's expedient that the data management activities are of a sufficient rigour to ensure that the data is not lost. So this section of the presentation talks a little bit about drivers for research data management, some sort of stories and anecdotes coming up. And the first driver for research data management is technology, as in it's now possible to do things which weren't possible before the development of the internet and ubiquitous sensors and fast networks and that kind of thing. So developments in sensor technology, in networking and in storage have enabled new research and scientific paradigms. As the costs have fallen, possibilities for data sharing, citation and reuse have become much more widespread, and we have a situation now where journals which are dedicated solely to publishing data have started to appear. So rather than collect a data set and then say, interpret it and say what you think it means, or say whether it supports a thesis or something like that, let's say the Geoscience Data Journal, which is the picture at the bottom right here. Simply, the papers in there are data papers which simply describe the data capture process, publish the data, and stop there. There's no interpretation. It's simply presenting a data set and a description of the way in which it was gathered, and then other researchers are encouraged to use that data for their own purposes. So this isn't new, because journals have always published research data, but not at such a scale and not with such structure. And it's the structure that makes this quite powerful, because structured data can be machine read, it can be machine processed, and the machines are obviously far more capable and reliable than humans. So we can do things now with computers which no human brain can actually accomplish. So this is a facsimile of some papers from William Parsons, who was an Irish astronomer in the mid-19th century, and he, at the end of his research publications, which were included in the Philosophical Transactions of the Royal Society, included some drawings of I guess nebulae or galaxies or something like that, of the apertures and the angles that his telescope and equipment were set at, so that other astronomers could see his working and and see if they agreed with his conclusions. Now, this data is obviously printed rather than created online, therefore it's not particularly processable. It's obviously not massively structured. It would be a difficult job to even to kind of screen scrape this stuff to make it machine readable. But the principle is the same, as in here's what I saw, do you agree with my conclusions? I mentioned before that funders are keen on data being repurposed, used for purposes used by researchers who didn't originate it, but reusing it. This is an example of a project called Old Weather, which is run by the UK National Archives. And what it is it's using citizen volunteers to annotate, or rather to transcribe ships' logbooks from the 18th, 19th and early 20th centuries. When these ships were sailing the seven seas, come rain, hail or shine, they recorded weather conditions at certain points each day, regardless of what was happening. The reason they were doing this was to ensure that they would reach where they needed to get to before they ran out of provisions. What they weren't thinking about was the way in which scientists 200 or so years from now, from then, would interpret that data and use it to understand how the climate in those areas had changed in the intervening period. So it's a very good example of data which was created for one purpose being reutilized for another, and it has the added flavour of involving the public in the scientific or indeed the research process. Funders now have increasing expectations that their researchers will take an active approach to research data management and, where it's appropriate, make their data more widely available. The major funders in lots of countries now have data management policies. They mandate data management plans. In the UK, the RCUK councils have 7 shared principles which underpin all of their individual policies. These very quickly are that data are a public good which should be accessible by the public and reusable by the public. That data should be preserved for the longer term, that data should be discoverable. There's a couple of points about rights, that confidentiality needs to be respected, the confidentiality of the subjects of research, that the researcher or the research team who create the data set or collect the data set have the first crack at the whip, so they get the right of first use via a process called embargo. There's the right to be recognised if somebody builds upon or cites data which you collected, and there's the principle which says that publicly funded data should be managed using public funds. 6 of the 7 RCUK councils require data management plans to be submitted at the application stage. The 7th doesn't require data management plans to be submitted, but does expect them to be created, so it's a slightly different tack. And the European Commission is running an open data pilot in Horizon 2020, and I'll talk more about that at the end of this presentation, and a little bit more about that this afternoon. Another driver for research data management is risk management. Universities tend to be quite risk averse, and they don't want to end up on a slide like this. So there have been in the UK a number of controversial freedom of information requests. One to the University of East Anglia about climate-related data, one to Queen's University Belfast about tree ring data, which climate change skeptics claim shows that the Earth is subject to natural periodic warming and cooling processes, and that ergo, in their logic, climate change is not man-made. And a less well-known one, but closer to my home anyway, is the University of Stirling, where the Centre for Smoking Research received an FOI request from Philip Morris, who are the makers of Marlboro cigarettes, among other things, asking for data which they had collected on the reasons why teenage children started to smoke. It wasn't collected so that tobacco companies could access it, but they didn't have a statement in place saying to whom and for what purposes they would give out the data. So it led to a freedom of information kind of battle between the company and the university, and it involved the Information Commissioner for Scotland. So universities don't want to be in a risky situation, and taking an active approach to research data management helps to avert that. I mentioned that the research quality and integrity argument tends to be the one best received by researchers. This is an example again from the UK, the UK and the US, about a piece of academic work which wasn't peer reviewed, so calling it research is a bit of a stretch. But a paper which was created by a couple of Harvard economists called Reinhardt and Rogoff, a paper called Growth in a Time of Debt, which was basically an article rather than a paper, not peer reviewed, and the data was initially not made available. It was, however, very influential paper, and it was repeatedly cited by politicians to lend weight to their economic strategy, notably the strategy of austerity and of cutting public services. There were multiple problems with the paper which were identified by a postgraduate researcher who attempted to replicate the paper's findings. This student, Thomas Herndon, was given a task by his PhD supervisor to replicate the findings of Reinhardt and Rogoff, and was unable to do so. He asked for the copy of the underlying data to see, which helps, being able to use the same materials that the original paper was written based off. And he found some issues in the spreadsheet, basically, which was that there were some countries in their analysis which had been selectively excluded deliberately. That is okay economically, because economics is about balance and opinions and things. Unconventional weightings, again, that's what economics does. But also a coding error, which was an accident. Basically, the paper shows, the paper's conclusion was that economic growth is only possible where the debt to GDP ratio is up to a certain level. But when they were calculating this, they forgot to include the first numbers of rows in the table, in their, in the Excel spreadsheet formula. So the countries that began with A and B were not included in this global calculation. So there was no Australia, Armenia, Azerbaijan, Belgium, Belarus, any of those places. And that was a genuine, a human error. That was identified by the postgraduate researcher, which led to widespread embarrassment. The authors maintained that it didn't affect their findings. The politicians obviously maintained that it didn't affect their their approach either, but at least the errors were discovered. And this is a really good example of a data management issue, or access to data, transparency of data, which affects everyone's lives in a very real sense. So very quickly, what this means for researchers is, make no bones about it, it's a disruption to their working processes. It's a new expectation and requirement. It's not always something that they welcome. But research data management provides opportunities for new types of investigation, new scholarly paradigms, and it leads to a far more robust scholarly record. The old way in which research was carried out necessarily was that a researcher would collect data or information, it would be interpreted or synthesized. The researcher would write a paper based on the data, and the paper would be published, and by publishing it, the scholarship is preserved. The data, however, was not preserved, it wasn't published, and it was left to benign neglect, put in a drawer or in a disk under a table or something like that, and it eventually would cease to be accessible. So what you have then is the tip of the iceberg, which is the published scholarship, but not the body of the iceberg, which is the evidence that underpins it. As I said, that was done from necessity, not from design, but it's no longer necessary. Timothy Vines and his colleagues recently examined data from over 500 studies of between 2 and 22 years old, and they found that the odds of a data set still being accessible fell by around about 17% each year. So that's why active intervention and indeed stewardship beyond the researcher themselves is important. And the way in which I formulate that is that if you don't do anything, data plus time equals no data. It will be lost if it's not looked after properly. The new way of doing things, ideally, is to put data in the centre of a research life cycle, informing everything from planning to collection, quality assurance, description, preserving the data, making it available for discovery, integrating it into new studies, and so on. The research cycle continues. And the ideal situation is that data is shared where that is appropriate, and it's reused, integrated into new work. What this means for universities is that they are developing three principal areas of focus. They have to develop and integrate technical infrastructures to manage data, and that can include storage space, repositories, current research information systems, data catalogues, and so on. They have to develop their human infrastructure, so they create policies, assess their current capabilities, identify areas of good practice, provide tailored guidance and training for their researchers. And the trickiest bit probably is developing business plans for sustainable services, roles to support research data management. And universities have formed cross-function hybrid working groups across different university services in order to tackle this sort of newish problem. For support staff, there's a need to understand the key elements in the process as well as roles and responsibilities. There's no need for support staff to become experts in all areas of research data management. What they need to know is the different responsibilities. Need to have a general big picture understanding of the process, the key points of funders' requirements, and to expect questions from researchers and to know where to direct them. In many cases, research data management is coordinated by either the library or the funding office or the IT service, but the expertise to answer specific questions about research data management will exist in different parts of different universities, and it varies from place to place. The three main roles that research support staff might have could be compliance, checking that researchers are sticking to their funder policies, and that's at both ends of the funding process. If the funder requires a data management plan as part of the application process, they need to make sure that it's done and done to a high standard, and at the end of the project, making sure that what was done has actually been delivered. Guidance, helping researchers to meet expectations and requirements, and some staff might also have a selection role. It's not beneficial to keep all data which is created as part of research projects. Some universities may want to make decisions about what data should be kept for the longer term, what should be shared, under what conditions, that sort of thing. There are various reasons why universities might want to keep some data sets and get rid of others. And as I said, different institutions will take different approaches to this, and there is no one-size-fits-all approach. For funder requirements, the DCC maintains an overview of the UK and European funders' data-related expectations and requirements, and we carry out training and things like that, and we're obviously part of the Foster project, which helps European universities and European, well, basically the European research community in meeting the European Commission's new open data pilot, and I'll be talking more about that this afternoon. Support staff should expect questions from researchers and know where to direct inquiries. They should also expect resistance. As I said, this is a new a relatively new area of activity, and it's not always well received by researchers, so it can pay to focus on the benefits rather than overemphasizing requirements and stipulations. But it is equally important to be clear that data management planning and good research data management practice are no longer optional for many funders and publishers, so by all means sympathize with researchers, but leave them under no illusions that if they don't do this, that their funding is at risk. So the last slide here are basically the take-home messages. Research data management is now an integral part of doing quality research in the 21st century. It's increasingly expected and mandated by funders, publishers and others. It's an opportunity for new discoveries and different approaches to research. It provides a safeguard against inappropriate data disclosure. And it is an activity that requires careful planning and consideration, and ideally coordination and support across multiple stakeholder types. So thank you very much. Obviously this is pre-recorded and I can't take questions just now, but if you do have questions, feel free to fire them to me via my email address, which is martin.donnelly@ed.ac.uk. Thanks.